Welcome back to my YouTube channel. Myself Aditi C. Gowda, presuming in Sri Venkateshwara College of Engineering from Department of Computer Science and Engineering. Subject Analysis and Design of Algorithm. My topic is insertion sort. So let's see what is insertion sort. Insertion sort is a simple sorting algorithm that works by iteratively inserting each element of an unsorted list into its correct position in a sorted position of the list. It is like sorting playing cards in your hands. You split the cards into two groups, the sorted cards and the unsorted cards. Then you pick a card from the unsorted group and put it in the right place in the sorted group. So let's see some key points of insertion algorithm so that we can easily understand. So they are: first pass, compare 1 with 23, current element with the sorted part. Since 1 is smaller, insert 1 before 23 and the sorted part until first index is 1, 23. So next, second pass, compare 10 with 1 and 23, current element with the sorted part. Since 10 is greater than 1 and smaller than 23, insert 10 between 1 and 23. The sorted part until second index is 1, 10 and 23. So next we come to third pass. Compare 5 with 1, 10 and 23, current element with the sorted part. Since 5 is greater than 1 and smaller than 10, insert 5 between 1 and 10. The sorted part until third index is 1, 5, 10 and 23. So next, fourth pass. Compare 2 with 1, 5, 10 and 23. Current element with the sorted part. Since 2 is greater than 1 and smaller than 5, insert 2 between 1 and 5. So the sorted part until fourth index is 1, 2, 5, 10 and 23. So final array that sorted is 1, 2, 5, 10 and 23. So next we come to the complexity analysis of insertion sort. In this they have two complexities, time complexity and space complexity. So let's see time complexities. In this we have three cases: best case, average case, worst case. So best case, if the list is already sorted where n is the number of elements in this list. So the best case is complexity of insertion sort that occur when the input array is already sorted. In this scenario, each element is compared with its preceding elements until no swaps are needed, resulting in a linear time complexity. Therefore, for the best case, time complexity is 0n, where n is the number of elements in the array. So next case, average case. If this list is randomly ordered, so this complexity of insertion sort is also a 0n square. This complexity arises from the nature of this algorithm, which involves a pairwise comparisons and swaps the sorted elements. Although the exact number of comparisons and swaps may vary depending on the input, the average case time complexity remains quadric. So let's see the worst case if this list is in reverse order. So in the worst case, time complexity of insertion occur when the input array is in reverse sorted order. In this scenario, each elements need to be compared and possibly swapped with a very preceding element, that resulting in a quadratic time complexity. Therefore, the worst case time complexity is 0n square, where n is the number of elements in this array. So next we come to the space complexity. Auxiliary space. Inserting a sort requires a 0-1 addition, making it in a space efficient sorting algorithms. So in this auxiliary space complexity of insertion sort, this 0-1 indexing, it uses a extra space regardless of the input size. This is because the algorithm typically perform in a place sorting, meaning it rearranges the elements within the input array itself without requiring additional data structures or memory allocation proportional to the input size. Therefore, regardless of this size of the input array and the amount of extra space used by the insertion sort algorithm, that remains constant. So let's see the applications of insertion sort. Insertion sort is commonly used in a situations where the list is small or nearly sorted, simplicity and stability are important. Used as a subroutine in a bucket sort, it can be useful when array is already almost sorted in a few very inversions. Since insertion sort is suitable for small-sized arrays, it is used in hybrid sorting algorithms along with other efficient algorithms like quicksort and merge sort. When the subarray size became small, we switched to insertion sort in these recursive algorithms, for example, intro sort and time sort that uses in a insertion sort. Thank you for watching my video. Please do like, share and subscribe my video. Thank you.